Hi, I'm Professor Baldwin, and today I'm going to teach you about complex numbers. Remember when you were first learning how to calculate square roots and you were told you couldn't take the square root of a negative number because it wasn't real? Well, today I'm going to teach you how to take the square root of a negative number. And if it's not real, then it has to be imaginary. And that's why we're going to talk about the imaginary unit I. I is equal to the square root of -1, or I squared would be -1. If you have the square root of -b, where b is some positive number, then that is equal to I times the square root of b. Think of it this way. You have the square root of -8. This is the same as the square root of -1 times 8. And applying that product property, that is the same as the square root of -1 times the square root of 8, which is I times the square root of 8. And then we could even go on and simplify the square root of 8, right? Square root of 8 is the square root of 4 times 2. So this would actually be 2I square root of 2. So to take the square root of a negative, we need to pull out that -1 factor and make that the square root of -1 on its own and simplify it out as an I. Let's look at a couple of examples. In example 1, we have the opposite of the square root of -16, or negative square root of -16. So let's break this all up. We have negative. The square root of -16 is the square root of -1 times the square root of 16. And now just go piece by piece. We have negative on the outside, which remember that's the same as saying like -1 times. The square root of -1 is I, and the square root of 16 is 4. So this is -I4. Doesn't really make sense. We put the negative first, then we put our coefficient, and I goes at the end. So it's written as -4I. Let's look at another example. Here, in example 2, there's a couple of ways to work this. First, we can multiply those radicands together and then simplify, or we can simplify each and then multiply. I'm going to simplify first just so I can get rid of these negatives. So square root of -6 is the square root of -1 times the square root of 6. Square root of -15 is the square root of -1 times the square root of 15. I can simplify this first square root of 1, that's I. Square root of 6, I'm going to rewrite that as the square root of 2 times 3. Remember, I really like to simplify my radicands before I multiply them all together. We have another square root of -1, that would be another I. And the square root of 15 is the square root of 5 times 3. Now we're going to move these coefficients, the i's, together. So I times I is I squared. And we're going to use our product property to combine our radicands here. So we have the square root of 2 times 3 times 3 times 5. Notice that the square root has 2 3's in there, or 3 squared. So we can pull that out, and we get 3 times I squared, and we're left with the square root of 2 times 5. A little more simplifying. We have 3 times I squared. Remember that I squared is -1 times the square root of 2 times 5, which is square root of 10. And simplify the 3 times the -1. We have -3 times the square root of 10 is our simplified radical form here. Okay, now we're going to look at some more complex imaginary numbers. When we talk about imaginary numbers, we need them to be in standard form. They need to be a complex number. And to be a complex number, we have A, which is the real part of that complex number, plus BI, where B is the imaginary part, not the I, B. The B is associated with the imaginary part, right? Okay, so what we need to do in our next example is get our simplified expression into this a plus bi complex number format. So notice that we have a numerator that has two terms, 14 and negative square root of negative 98, and we have a denominator with one term. First, let's simplify this numerator because I can see some things I can simplify out of that square root. So our numerator is 14 minus, we have the square root of negative 98. So I know I can pull out the square root of negative 1 first. And then I have the square root of 98. And we'll keep this over the negative 7. Well, simplifying that square root of negative 1, we have 14 minus I times the square root of 98. But 98 is also 49 times 2. Yep, you see what's in there. Okay, our first term stays as 14. Minus, we have our I, but notice we can take the square root of 49, which is 7. And we're left with the square root of 2. And then this is divided by negative 7. So everything is simplified in the numerator and the denominator. So now we can break it up. Because we have one term in the denominator, but we have two terms in the numerator, we can make this two fractions. And that becomes 14 over negative 7 plus a negative 7i square root of 2 over negative 7. Now we can look at how to simplify. Well, 14 and 7 share a 7 in common. But there's a negative, so it stays negative. And we're left with the 2 in the numerator, right? Because 14 is 7 times 2. Our next term, these two negatives simplify out. Negative divided by a negative becomes a positive. And then notice that the numerator and the denominator both share a 7 in common. So that simplifies out to 1, and we have I square root of 2. So this simplifies as negative 2 plus I times the square root of 2. Or sometimes you may see it as negative 2 plus the square root of 2i. Personally, I like the I first, just so you're not confusing it as being inside that square root. You'll see where that confusion can come up in an example in a little bit. Okay, how do we add and subtract these complex numbers, these a plus bi's? It's pretty easy. You add all of the real parts together and you add all of the imaginary parts together. So this first example, we're going to distribute the negative, the subtraction first, and then we're going to group our like terms. We can get rid of the parentheses for the first grouping because there's no negative on the outside. The second grouping, we're going to distribute that negative to get negative 18 plus a 40i. Now we're going to rearrange and group our like terms. We have 15 minus 18 plus 21i plus 40i. So I have the real parts together at the beginning, and I have the imaginary parts together at the end. So at the beginning, I have 15 minus 18, which is negative 3. And the last two terms, I have 21i plus 40i, and we just add the 21 and the 40, which is 61i. As simple as that. Just remember, you want your a plus bi. So the real part always comes first, and then that imaginary part is last. How about multiplying? Multiplying, you multiply just like you would multiply everything else. Distribute or use FOIL. You just have to remember the property that I squared is equal to negative 1. Our first example, we have 4i that needs to be distributed to the two terms inside the parentheses. So we have 4i times 6 plus 4i times 5i. Multiply the coefficients together. 4i times 6, you're multiplying the 4 and the 6, and you have 24i. 4i times 5i, you multiply the 4 and the 5 and you get 20. You multiply the i's and you get I squared. But remember, I squared is -1, so we have 24i plus 20 times, replace the I squared with -1. So this becomes 24i minus 20. Correct, just not in the right format. Remember, it needs to be the real part, then the imaginary part. So we rewrite this as the real number, -20, plus the imaginary part, 24, and our I. Okay, how about example 2? Example 2, we have two binomials, so we're going to FOIL. Multiply those first two terms together, 3 times 10, which is 3 times 10. Then we have the outer, plus 3 times I. We have those two innermost terms, which is a -6i times 10. And we have our last two terms, -6i times I. And then just slowly simplify. 3 times 10 is 30, plus 3i. 6i times 10 is -60i. And our last term, we have -6i times I, which is I squared. Okay, now we look. Can we combine any like terms? Yep, the middle two terms. So our 30 stays put. Then we have 3i and a -60i. Remember, we look at the coefficients. Plus 3, -60. That would be a -57i. And then look, our last term is the -6i squared. And I squared gets replaced with the -1. Again, we keep our 30. No more i's to add to our -57i. And at the end, we have -6 times a -1, which is a +6. That gave us another real number part. So we're going to add that 6 to our 30. And we simplify to 36 minus 57i. Okay, look at question 3. Question 3 is the tricky question I was hinting about earlier. Notice that our i's here are not inside the radical. I hate when they're written like this, but it happens. So pay attention to where that square root or radical bar ends. Here, the I is not inside. What else do you notice about 3? 3 is a product of conjugates. Remember the product of conjugates? The first terms are identical, square root of 2. The last terms are identical, square root of 3 times I. And our signs are different. One's positive, one's negative. So product of conjugates says you square your first term and you subtract the square of your second term. So square root of 3 times I and the square root of 3 times I. Remember, the square root of 2 times the square root of 2 is the square root of 2 times 2. Likewise here, the square root of 3 and the square root of 3 is the square root of 3 times 3, and we have an I squared. You take the square root of 2 times 2 and you have 2, minus the square root of 3 times 3 is 3. And remember, I squared simplifies to -1. So here we have 2 plus 3, or this crazy thing simplifies down to just a 5. Because the product of conjugates, it was able to eliminate those radicals. Okay, what if we're dividing complex numbers? When you're dividing complex numbers, it's similar to when you're dividing with a radical. You can't have a complex number, an I, in the denominator. It's bad math grammar again. So we need to multiply by that complex conjugate. So we need to look at our denominator, determine the conjugate, and multiply the numerator and denominator by that conjugate. But then we have to write in standard form. So we always have to have our final answer as a plus bi. We need a distinct real part and a distinct imaginary part. So look at our example here, number 4. We have an I in the denominator, which is a big no-no. So we need to multiply by that complex conjugate. So the first term stays the same and the last term stays the same. I don't know why my document wanted to give me a 3 there. And we change the sign in between to be the opposite sign. And because we have to multiply the numerator by the exact same thing, we multiply it by 3 plus I. So let's rewrite this and look at what we have. Our numerator is going to be 6 plus 2i times 3 plus I. And our denominator is going to be the product of conjugates, 3 minus I times 3 plus I. Let's start in the numerator. We're multiplying the first terms together, 6 times 3, which is 18. The outermost term, 6 times I. The innermost terms, that's another 6i. And our last term, 2i times I, which is a 2i squared. And then probably the easier part, the denominator, because it's multiplying the conjugates together, we have our first term squared minus our second term squared. So we have 3 squared minus I squared. Okay, let's simplify. Our numerator, we have 18 as our real number. The next two terms, 6i plus 6i, are like terms, so we can combine those to become 12i plus 2 times I squared. Remember, I squared is -1. And then our denominator, 3 squared is 9 minus I squared, which is again -1. Okay, let's keep simplifying. We have 18 plus 12i so far in the numerator. And then we have 2 times -1, so that's -2. And our denominator becomes 9 plus 1. Okay, we still have some like terms to combine. In the numerator, we have an 18 and a -2 for our real number part. So 18 minus 2 is 16 plus 12i. Okay, our numerator is simplified, and our denominator is 9 plus 1, which is 10. Okay, everything is simplified, but we're not in standard form. So we need to get this into a plus bi. Remember, we have 2 terms in the numerator, 1 term in the denominator, so we can break that up into 2 fractions. The first term over the denominator plus our second term over the denominator. And then we can simplify. 16 and 10 are both even. We can divide them by 2. That becomes 8/5. And likewise, 12 and 10 become 6/5. And then we have our I. So we have our real number part, 8/5, and we have our imaginary part, 6/5, and our I. Thank you for watching. I hope you found this video helpful, and if so, I hope that you will go check out my other math videos for even more help.